How's everybody doing? We're going to do a video explaining the practice quiz 1.4, which is strictly on distributive property and combining like terms. We have our first question here, and most of the time we say, look at inside of the parentheses, is there anything to do in there? No. So what else is there? What other operations are there? Well, you can't subtract because those aren't like terms, but there's multiplication here, and that's where we distribute, right? Distributive property. Take this 5, distribute. 5 times 3x is 15x. 5 times, I want to call this a negative 8. 5 times negative 8 is negative 40. But instead of writing it as a negative 40, I just put it as a minus 40. A minus and a negative, pretty much the same thing, right? Anyway, there's our answer, 15x minus 40. I believe on this quiz you're going to be typing this in with no spaces between your terms. Let's move on. Number 2, again, we are distributing. There's really the multiplication of negative 4 that I need to distribute to both terms inside of the parentheses. Now, again, the only reason why I'm going to distribute is because I cannot combine these terms. If this would have been a negative 11x, then I could combine the negative 3x with the negative 11x, and that would give me a negative 14x, and then I would multiply by negative 4. But since I cannot combine these, I'm going to distribute the minus 4. Minus 4 times minus 3x, a negative 4 times a negative is a positive 12 with an x. Negative 4 times a negative 11, that's going to be a positive 44. And of course, we cannot combine these. We are done. This is simplified. 12x plus 44. Is it getting more fun? Absolutely. We have 2/3 right here. So I'm going to distribute the multiplication of the fraction 2/3 times a 3x. Now, sometimes you'll be able to do this in your head, but I obviously am going to show it right here so you could see everything that's going on. I'm going to write it out. 2/3 times, that is a 3x, right? Now, we're going to put that 3x over a 1, and you have a couple of options here. You could multiply the top with the top and get 6 up here, and 3 times 1 and get 3 down here, and 6 divided by 3 is 2, okay? Or another option is to recognize that there's a 3 up here and a 3 down there, and that's like having 3 divided by 3, which will cancel out, okay? So that does cancel out. And what do I have left? I have my 2 times x, which is 2x, and 1 times 1, which is 1. And you're not going to write it 2x over 1. Anything over 1 is pointless to write over 1. Might as well just leave it as 2x, right? 2x divided by 1 is exactly that, 2x. So far we've distributed this into that, and we showed our work, and we got 2x. Now let's distribute the 2/3 to the negative 6. Okay, and let me show my work again. I have 2/3 times, I want to call this a negative 6. I am going to put it over 1. And again, I could cancel the 6 with the 3. If I reduce by 3, I'll have a 2 up on top and a 1 on the bottom. That's just the way we canceled over here, right? We could cancel the 6 and the 3 and have a 2 left over up on top. But just for the sake of making it a little different, I'm going to multiply the top with the top and the bottom with the bottom. So 2 times negative 6 is negative 12. And 3 times 1 is 3. And then you could reduce that fraction or divide that fraction. Negative 12 divided by 3, that is a negative 4. Okay, so this is a negative 4, and I'm going to write it down here, negative 4. Okay. Again, you could reduce first and then multiply, or you could multiply first and then reduce. Okay, so it's totally up to you. I did it both ways there. Anyway, there is our answer, 2x minus 4. There's nothing else to do. 2x minus 4 is the correct answer to number 3. All right, more fractions. Let's distribute this negative 1/2. Negative 1/2 times 6. Negative 1/2 times 6x. Put that 6x over a 1. And you could cancel first, you could reduce first and then multiply, or multiply first and then reduce. It's totally up to you. I am going to reduce first. 6 divided by 2 is 3. 2 divided by 2 is 1. And then I'm going to multiply negative 1 times 3 with an x. Negative 1 times 3x is negative 3x. Negative 3x. And of course, the negative 1 times 1, or the 1 times 1, we put the negative up on top, not on the bottom. 1 times 1 is 1, but we are not going to write the 1 down there. That's totally pointless. Let's just leave it negative 3x. And then we're going to do the same over here. Negative half times negative 4, right? Include that minus sign, make it look like, or make it, pretend it's a negative. Negative times a negative is a positive, okay? So if you want, you could just put a plus sign right here because we know it's going to be positive. But I'm going to show my work. What is 1/2 times 4? And you could put the 4 over 1, and you could reduce first and then multiply, or you could multiply first and then reduce. I want to multiply this time. That's going to be a 4, multiply, it's going to be a 2, and 4 divided by 2 is 2, right? 4 over 2, that's really 4 divided by 2, and that is 2. And there's your answer to number 4. This could have been done without showing the work. Now, how is that? Well, if you're distributing 1/2, everybody should know how to multiply by half, because that's really like just taking half of something. So when you say half times 6, what's half of 6? It's 3. Half times 4, what's half of 4? It's 2. So it's really easy if you understand multiplying by half. So you didn't have to show all this work. Always be careful that it's a negative. So negative times a positive, that's going to be a negative. Negative times a negative is going to be a positive. There you go. Moving on. This is too easy. All you're doing is really combining like terms. You have only 2 terms. There's 3x's here. There's negative 9x's here. It's like if you have $3 and you owe $9, you're still gonna owe 6 of those dollars. But in this case, we don't have dollars, we have x's. And that's it. That's your answer, negative 6x. Some more combining like terms. This time we have 4 terms, and out of those 4 terms, I could combine the x's with the x's and the numbers with the numbers. And I always like to use circles, underlines, squiggly underlines, whatever it takes, right? I got 12x here. I want to combine that with negative 3x. And notice that when I do circle them, I include the sign that's in front of that 3x because that tells me that I owe 3 of those x's or owe 3 of those dollars, whatever you want to call it. We have 12. We have 12 because that's positive 12. We owe 3. If we have 12 and owe 3, we're going to have 9 left over. So 9x is the first part of your answer. Then we move on to the numbers. We have a positive 7 here and a negative 10 there. We're going to owe 3 of those dollars or whatever you want to call them, right? Positive 7, negative 10. You have 7, you owe 10. You're going to owe 3. There's your answer, 9x minus 3. Oh man, look at that one. That one's long. Yep, let's do it. Is there any distributive property here? Absolutely not. Right? You might be thinking, well, there's parentheses. Yeah, but there's nothing to do in parentheses. Actually, right here, there's parentheses, and you have a minus minus, and we know that we need to change that to plus plus, right? That's about it. So we know that we're thinking of money on all of these. Why is that? Because there's a sign between the 3 and the 7. There's a sign between the 9 and the x. There's a sign between the 9 and the 2. There's a sign between that parenthesis and that parenthesis. So we're thinking of money, and let's combine the x's with the x's and the numbers with the numbers. So in this case, we have 3 different x terms. We have negative 7x that could be combined with positive 2x. Okay, so let's think about that. You owe somebody $7, you have $2. You owe somebody 7, you have 2. You can't pay them off, you're still gonna owe 5. If you want, jot that down somewhere. I'm gonna put you owe $5, okay? Now, is there any other x's? Yeah, there's this one over here, plus 5x. That means that you have 5x's. So what happens when you owe 5x's and you have 5x's? Well, both of those eliminate. That's like saying I owe $5, I have $5, I don't have any money left. It eliminates. So all of my x's just eliminated, right? I hope that's not confusing to you guys. The negative 7x and the positive 2x gave me a negative 5x. But when I combine the negative 5x with the positive 5x, that eliminated. There are no more x's. Now moving on to the numbers, we have a negative 3 plus 9. If you owe $3 and you have $9, you're going to have 6 left over, right? The negative 3 and the 9, that gives us a positive 6 left over. Okay, so I put 2 arrows showing that the negative 3 and the 9 gave us 6. But then we have plus negative 6. So we have 6 and we owe 6. Those are going to eliminate. So guess what? Everything eliminated. Okay, everything eliminated. So my answer is 0. Okay, I do feel like that was kind of confusing. So let me go back to this. Let me try to make it a little less confusing. Let's combine all the x's at the same time. Look, I owe 7, I have 2. I'm going to owe 5, right? Owe 7, have 2, you're going to owe 5. That's a negative 5. And then plus 5, that's going to be 0. So the x's all eliminated. All right, now I owe 3, I have 9, I'm going to have 6 left over, but over here I owe 6. So even though I had 6 left over, then I owe 6, that's going to eliminate also. So everything eliminated, the answer is 0. I hope that makes sense. Let's move on. Get into a question where we have both distributed property and combining like terms. Okay, so let's go through PEMDAS, even though it's not really necessary, but going through PEMDAS, we have parentheses. Is there anything to do inside of the parentheses? No, you can't subtract x's and numbers. Those are not like terms. Okay, so what else do we have if we can't do anything inside of the parentheses? We have addition and we also have multiplication. Obviously, we have to multiply first, but we are multiplying this -3 into the binomial inside the parentheses. So I'm going to distribute -3 times 5x, that's -15x. -3 times, I want to call this a -7. A -3 times a -7 is a positive 21. And then I'm going to bring down that +9 out here at the back. So now I have 3 terms, and out of those 3 terms, I could combine x's with x's and numbers with numbers. That means I want to combine the 21 with the 9, and that'll give me 30. So my final answers are going to be -15x plus 30. Okay, and that's it. Let's move on to the next question. Okay, so we're going to begin this expression. We're going to begin simplifying it by distributing, and we're going to distribute the -1/3. I always say circle what you're going to distribute and include the sign that's in front of it. So that's a -1/3, and I will show my work here. -1/3 times 9. Okay, that is going to be a -1/3 times 9 with an x. We're going to put that 9 over 1. And you could multiply top with the top, bottom with the bottom, and then reduce. Or you could reduce first, like the 9 and the 3. They're both divisible by 3, and then multiply. So it's totally up to you. I am going to multiply the top with the top, all right? So -1 times 9x, that is a -9x. And 3 times 1, that is a 3, okay? So we now have a -9x divided by 3. And that could be done. -9 divided by 3, it is -3. And what about the x? Well, it's still there, so -3x is your answer, okay? I don't know, that might not have been all that great to understand. You could have also, from the beginning, said, okay, 9 divided by 3 is 3, and 3 divided by 3 is 1. And then you could multiply -1 times 3. That gives you a -3x, right? -3x. And 1 times 1 is 1. So -3x over 1, you don't need the over 1, so you'd get that same answer anyway, -3x. Let's distribute over here. -1/3 times 6. Okay, let me show my work over here. 1/3, -1/3 times 6. And let's put that 6 over 1. And you could multiply the top with the top, bottom with the bottom, and then reduce. Or you could reduce first and then multiply. I'm going to reduce first this time. I'm going to cancel out the 6 divided by 3 is 2, and the 3 divided by 3 is 1. So what's left? I have a -1 times 2. That's -2. And 1 times 1 is 1. It's still going to be a -2 over 1. So I'm just going to leave it as a -2. Okay? So I hope this helps. There's obviously easier ways of doing this without doing all this work. If you truly understand what 1/3 really means, it's kind of like dividing by 3, okay? Just like 1/2, what's 1/2 times 20? What's 1/2 of 20? The answer is 10. 1/2 is really like dividing by 2. So 1/2 of 20 is 10 because 20 divided by 2 is 10. 1/3 is the same thing as, when you multiply by 1/3, it's the same thing as dividing by 3. So 9 is divisible by 3. So -1/3 times 9, that's like saying 9 divided by -3, that's -3. -1/3 times 6, that's like saying 6 divided by -3, that's -2. So that's how you get those answers without showing that work, if you understand that 1/3 is like dividing by 3, okay? Anyways, that's our answer. Let's move on. Double distributive property, you gotta love it, right? Let's distribute 4 times 5x, that is 20x. 4 times -2, that is -8. Let's actually make this a little bigger, why not? Okay, and then we're gonna distribute over here. Now you're thinking, wait, there's no number out here to distribute. That's true, there is no number out here to distribute, but we do have a minus sign. And if there is no number, there's technically like an invisible 1 right there if you wanted to. Or you could just distribute the minus sign, right? It's up to you. But you will have to distribute the minus sign, which is kind of like distributing the multiplication of -1. So -1 times 12, that's -12x. Negative 1 times negative 4, that's positive 4. So we have these 4 terms, and we're going to combine the x's with the x's. 20x, take away 12x, that gives us a total of 8x's, or actually 8x's left over, right? 20 take away 12 is 8. And then we combine the number negative 8 with the number 4. That'll give us a negative 4, right? If you owe $8 and you have $4, you could give the $4, but you're still going to owe 4 more. So 8x minus 4 is our final answer to this question. Let's check out our last question of this video. This one is super fun, as you could see. Yep, we are distributing fractions, and we're going to show our work because it's going to be a long process. 2/3 times 2x. Let me actually write 2/3 times 2x, and I am going to put that over 1, okay? Now notice I can't cancel the 2 with the 3 or the 2 with the 3 or any, I can't cancel it. So I actually have to multiply 2 times 2. Of course, there's an x right there. So 2 times 2x, that is 4x. And 3 times 1, that is 3 on the bottom. So when I distribute here, this is what I get for my first term. Now let's distribute the 2/3 times negative 1. That's pretty simple. 2/3 times negative 1, that's just going to make it a negative 2/3, right? Anytime, any value times negative 1, it's the same value but with the negative sign. So I'm going to put negative 2/3 right here. Okay, same value with the negative sign. So I distributed, I got this, I distributed, I got that. Now let's distribute this other one. We have negative 1/3 times x. That's like saying negative 1/3 times 1 in front of the x. So it's not going to change. It's going to just be negative 1/3 with an x, right? You could put the x on top or on the side. I would probably put it on the side. And also this x, it's probably better to put it on the side. We'll do that in a little bit. Let's distribute to the other one. Negative 1/3 times negative 1/2. Right there for sure I'm going to show my work. I have negative 1/3 times negative 1/2. Well, first of all, a negative times a negative is going to be a positive. And let's actually multiply top with the top. Like I said, negative 1 times negative 1, that is positive 1. And then the bottom with the bottom, 3 times 2, that is 6. Okay. And what else? Well, the negative 1/3 x also comes down. I apologize. Negative 1/3 x comes down. And like I said, let's change this 4x to a 4/3 with the x on the side. So I just changed that. Instead of having the x up here, I put it to the side. Now we have 1, 2, 3, 4 terms that I need to combine. Obviously, we're going to be combining the x's with the x's and the numbers with the numbers, even though we have fractions. Okay, so when we combine the 4/3 x with the negative 1/3 x, that is a beautiful thing. Why is it a beautiful thing? Because I actually have a common denominator here. So it's really easy to combine the 4x with the negative 1x because the common denominator is just going to stay as a denominator, right? In order to add or subtract fractions, you need a common denominator, and we got lucky because we already have a common denominator here. So what is, when we look at 4, take away 1, that's going to be 3, okay? So our answer is going to be over the common denominator, 3, and once again, 4x take away 1x. What is 4x take away 1x? Well, that is 3x, right? 3 with the x on the side. And the beauty of this answer is that 3 over 3 is just 1. So I really just have 1x, or just x, okay? And now let's combine the fractions. I want to combine this negative 2/3 with the plus 1/6. Let me actually show my work here. Negative 2/3 plus 1/6. Now, in order for me to add two fractions or combine two fractions, I need a common denominator. So right here I have a 3 and a 6. What is my common denominator going to be? Go to the bigger one. That's the number 6. Could you change 3 to become 6? The answer is yes. All I need to do is multiply it by 2 and multiply the top by 2, and I'll be ready to go. So that'll give me a negative 4/6 plus 1/6. And now that I have a common denominator, I could combine the top with the top. Negative 4 plus 1, negative 4 plus 1 is negative 3, and it is over 6. So ladies and gentlemen, so far our answer, let me see, here we go. Our answer is the x, right? and then minus 3 over 6. Now the only thing we have to do now is try to reduce that fraction, which we actually can do. The 3/6 becomes 1/2 if you reduce by 3. So there is your final answer right here, x minus 1/2. That is your final simplified answer for this pretty long variable expression that we just simplified. It's the hardest one. I hope you guys understand it. Good luck on the quiz.